This conference will now be recorded.
Yeah, in today's session, we're going to discuss about creating a decorator inside a class. Till now, we have seen how to pass one function to another function. You term that as a decorator. Now, I'm going to say how to create a decorator inside a class. Okay. Now, we can easily create a decorators inside a class, and this easily accessible from the child class. Now, what I'm going to do, I'm going to have two more classes. One is called parent class, another one is child class. In the parent class, I'm going to have the decorator function. Through child class, I can able to access my parent decorator. Through my child class, I can able to access my parent decorator. That thing I'm going to show now. And then whenever you are using decorator function in the parent class, that parent class will take current object reference self as a parameter, self as your parameter. And then when you are trying to call the decorator from the child class, we want to call the decorator using the class name. That thing I'm going to show now. Okay. uh, don't think in mind decorator is only for just you want to pass a function to another function. That's not decorator. You can create a decorator inside a class also. You can get a decorator, but here no classes in the current program. You can see the chain decorators. In the chain decorators we can't able to see the class. Once you have the class, you can able to create an object. For this py file, I'm not able to create any object because I don't have any class, right? That's why now my focus is how to create decorator inside a class. How to create a decorator inside a class. I'm going to have the number as decorator underscore 9. Decorator underscore 9. I'm going to have a command line as create a decorator inside a class. You all know what is decorator without affecting the old object. Old object means old function. I'm going to modify the new functionality. I'm going to make a new functionality without touching my old object. I can able to create a new object from the existing object. I can able to create a new object. That is nothing but decorator. I already said so many examples. Your lead is saying don't touch the old object. You can use your old object and then you can create a new functionality for your existing object. That is nothing but decorator inside a class. Now, what I'm going to do, I'm going to have an example, simple example first. Uh, Before going to the parent child class, now I'm going to have only one class. Give class name. The class name is I can give like check number. I'm going to check whether the number is odd number or even number. Okay, I given the class number as class name is check number. Inside, I'm going to have one decorator function. Decorator function. I'm going to have one decorator function. Now I'm going to have one function. I'm going to give its decor. Decor means it's a decorator function. Okay, and then you already know I want to get function as an argument. Function as an argument to my enclosing. This is my enclosing function, decor function. I'm going to get another function as an argument. Okay, use func, or you can use some other name also, no issues. Okay, you can use func underscore one, anything you can use. I'm going to give the function, and then I'm going to have one more function called wrapper function. I'm going to use, for your understanding, I'm going to use wrapper. Okay. Inside the decor function, the first argument should be a self keyword you have to use. Self is nothing but referring the current class instance. If you want to create an object for this class, the class will have a current class instance. Okay. Keep in mind this is a rule actually. When now creating some wrapper function, wrapper means nested function, the first argument you have to pass as self. Self is nothing but referring the current class object, or you can say it's a current class instance. And then I'm going to perform odd number or even number. I'm going to have one argument called number. Okay, and then now I created a decor function. Inside decor function, I have a one wrapper function, and then what I'm going to do, I'm going to have this function, and then the argument is first argument is self, and then I'm going to pass a number. Because in the decor function I'm going to pass one function as a parameter. Okay, till now I didn't write this function. Later I will write this function. Okay, later I will write function in the after completing my decor function. Now keep in mind, whenever writing some wrapper function, the first argument should be a self. Self is nothing but referring to current class object. Okay, if you're creating a object for this class, you want to, it will refer to the current class object, and then I'm going to pass only one argument, that is called number. And then whenever you calling this wrapper function, it's going to call your old function. Okay, after calling the old function, I'm going to check one if condition. If number modulo of 2 is equal to 0, I'm going to say the number, what number it is, it is a even number, going to be a even number. Yes, it is your even number. Else you can use else statement, print number is going to be a no, the number is going to be a odd number. It is a odd number. Okay, it is a odd number. And then what you have to do, if someone is calling the decor function, you have to return the function, right? You have to return the function. See the indentation. The indentation previously it was here. Just come out of the indentation and then come out of the indentation and give the return statement. Return of, I'm going to use a wrapper. If someone calls the decor function, it's going to give the return as a wrapper. It's going to call the wrapper function and it's going to compute this existing object. And then from the existing object, I took the number and then number divided by 2. If it is even number, otherwise it's going to give the odd number. Okay. Now I added a decor function. Now I'm going to have one instance method. For this class, have one instance method. Instance method, and then I'm going to write. Okay, hold a minute. Yeah. If, and then I'm going to write whether I'm going to check even number or not. Is even, and then the first parameter you have to pass self keyword is nothing but referring the current class instance, and then I'm going to pass a number, and then what I'm going to do, I'm going to have one print statement. It's my user input, right? It's my user input. Whatever input I'm giving over here, it's going to display in the print messages. User input is, for example, if I pass 5, it's going to print user number input as 5. Okay. Now you have to say there are two methods. Sorry, there are two ways I have said to you how to pass this function to my decor function. Through py syntax, you can pass this function as a parameter to the decor function. That's the first way. Second way is, first we'll go for first way. What are you to use? You have to use a py syntax. Py syntax means at the rate of, you have to pass decor. Now this function will be passed as an argument to decor function. That's the meaning of the at decor. This is the first way actually. Okay, that's one more way is the, okay, you have to create one variable, take some variable is equal to, and then you have to pass like this. Okay, just I go and comment these things of now. I will come in the comment line. I'll mention take some variable y equal to decor of, you can pass EC1. Decor of EC1 you can pass. Okay, and then what are you going to do? Y of, I want to pass the, how many arguments I want to pass? Only one argument I pass. I want to pass y of I want to pass. This is another way. Okay, out of these two ways you can follow any one way. Now we are used py syntax, and then you are passing argument to the decor function. Now for this class I want to create an object. How to create an object for this class? Can you say how to create an object for this class? Object reference, object reference or self instance you can say. Okay, instance or object reference, anything you can say. I'm going to give some like any reference you can give. Object underscore one you can give, and then what you can give? You can give the class name. Class name, and then you have to call the constructor. If you are using the brackets, it's going to call the constructor. But in here, I didn't mention any constructor as of now. It's going to call the default constructor. It's going to call the inbuilt. By then we have default constructor we have. It's going to call the default constructor. Okay. Now, what I'm going to do? I'm going to call this method. How to call this method? I want to call this method EC1 because I want to pass argument, right? I want to pass some value. Number is 5. I want to pass. How to call this method EC1? Object one is nothing but the instance, that class instance you can say. Using class instance you can call. How to call? Object underscore one dot like EC1. Okay, I want to pass some values. What value am I going to pass? Somewhat I'm going to pass 37. 37 is odd number or even number? It's a even number.
Odd.
Yeah, sorry, 37 even odd number. Okay, fine. Yeah. I'm going to make like 39. 39 is going to be odd number. Fine. Okay. Now I'm going to, it's going to give, no, it's an odd number. What will happen? The backend, through class, I'm using decorator function, right? I'm calling this method. In the method, I'm passing the value 39. What will happen? This function will be passed an argument to the decor function. You can see func over here. Instead of func, you can substitute EC1. You have to substitute only EC1, okay? Because you have used only func over here. You have to substitute only the function name here, and then this decor function will return the wrapper function. Again, control transfer to the wrapper function. In the wrapper function, it's referring to the current class instance. Self is nothing but you have to substitute object underscore one. You have to substitute. Instead of self, you have to substitute object underscore one, and then instead of number, you have to substitute 39. The parameter will pass to this function. Now, what is func name? Func name is EC1. I already said to you, instead of func, you have to substitute EC1, right? Now, instead of func, you substitute EC1, and then instead of number, you have to substitute 39. Instead of self, what you have to do? You have to substitute object underscore one. After that, it will call the this function, user input value will be, what are the values you have passed, right? 39, that value put it over here. After that, you are writing some additional functionalities without touching your old object means old function is nothing but object actually. Without touching the old object, you are adding your new functionality. This is nothing but a new function. What are highlighted, right? Functionality. It's your even number, and then it's going to odd number, and then you go and check the number. 13 model of 2 is not going to give any reminder, so it's going to print it's an odd number. Okay. Now you have seen a single class. Now we're going to have two more classes. One is parent class, another one is child class. Okay. For that, what I'm going to do, I'm going to have one more program. That program is, you're going to have some marks, 45, 55, 65, the student marks, and then going to show the grades to them. Like 90 means A grade, 80 means somewhat B grade, like that you're going to display various grades. Okay. Now I'm going to use a decorator. I'm going to have two classes. One is parent class, another one is child class. In parent class, we have a decorator. Child class, we're going to have a existing object. Child class, we're going to have a existing object. That thing we're going to try now. Now new of, have a py file. Now I'm going to see what I'm going to do, right? Decorator of underscore parent. Keep in mind this is a parent class actually. I close the remaining stuffs. Now I'm going to have the class name as student. See, this is a parent class actually. In that class, I'm going to have only the decor function. The existing function I'm going to keep in child class. Now I'm going to say how to call the decor function from the child class, as well as how to reuse the existing function from the child class. These are things we're going to discuss now. Now I'm going to have one function called decor function. You can give some name, any name you can give. Okay, decor function, and then you have to take function as an argument. Sorry, you have to going to take function as an argument, and then you're going to have grades, right? The wrapper function is nothing but, you can say wrapper function, or you can say it's now giving the name is grade. What is the first argument you have to pass? For a wrapper function, if it's a class, self keyword you have to pass, right? You have to pass the self keyword, and then I'm going to have one more additional parameter called marks. You can say it's argument as well, and then I'm going to call that function. What function are you going to call? I'm going to call the existing object. Existing object means functions object actually. I'm going to call the existing object, and then the existing object also have the self keyword. So I am referring the current class instance, and then marks. Okay. Now I'm going to have, why it's throwing here. I think we have used the colon. That's a mistake. Edit. And then I'm going to have an if condition. You already know, right, how to find the grades. If marks less than 35, what grade I can give? I going to give grade F. Grade is F. And then you have to use elif marks less than 50. I'm going to give E grade. This we're going to copy and paste. How to save the time. Okay, what I'm going to do, right? I'm going to copy paste because we have so many grades, right? With a proper indentation. Now 50, and then what I can do, like 50, 35, 50. Can I keep 60? Yeah, 60, 70, 80, 60, 70, 80, 80, and then you can make it 90, and then you can keep it as 100. And then you can change the grade as well. Grade F, and then you can change the grade as E, B, and then you can grade to make it C, B, and then make it grade A and A plus, or you can keep like lesser than or equal to with 100 or less than equal to 100. Okay, not issue. This is my decor function. Okay. See, whenever using decorator, you should have enclosing function as well as you have here some nested function. Okay. The nested function is nothing but a wrapper function. In the wrapper function, you have to call the existing object, and then this is your new functionality. Without touching the old functionality, you are writing the new functionality as per the client requirements. Now, what you have to do, and then if someone calls the decor function, it has to call the wrapper function, right? So that I have to use a certain keyword. Come out of this elif statement and then use one return keyword, return of grade. Fine. Use some reformat the file. Okay, I reformat the file. Now, this is my parent class. I'm going to have one more class. Now I'm going to say what is inheritance. Inheritance topic will be discussing later, but I'll give some hint what is inheritance. The class name, py file name, I'm going to keep it as decorator underscore child class. Child. Okay. Now split the window. Okay, this is my parent class. Student class and parent class, and then I'm going to have one more class. The class I'm going to have like result. I'm going to have result. Now, what I'm going to do, I want to inherit the properties from my parent class. From child class, I want to inherit the properties of my parent class. Properties means it can be variables, it can be functions. I want to access this function in the child class. That is nothing but inheritance. Inheritance nothing but you're going to inherit the properties from the parent class. For example, your mom is having around 15,000 of gold. For your marriage, what will you do? You will get the properties from the parent, right? You get the gold from a parent. Same thing. The result is sand. Keeps result is sand. Student is mom. You are trying to inherit the properties from your parent. That is not an inheritance. Inheritance first advantage is you can do the code reusability. You can do the code reusability. Again, writing the same code in the child class. It's a waste of time as well as what will happen? It will create a performance issue as well. If the parent is having some function, why can't you use a function? You can use the same function. You can reuse that function whatever your parent have. What are the parent having some properties like gold or a land property? You can take that property because you are child, right? That is nothing but your inheritance. See, inheritance is a big topic actually. I agree. For your understanding, I am giving some hints to you. Inheritance is nothing but inheriting the property from the parent class. What you have to do, you have to use the brackets and then you have to call the parent class. Now I'm trying to inherit the properties from my parent. It will throw compile time error because we want to import, right? We want to import. From which one you're importing? You have to use import statement. Import. What I can do? Hold a minute. Import. What's the py file name? Decorator. Sorry. From decorator parent. Import import student. Now it won't throw any compile time error. Your interpreter won't give any error because from the file imported this class, right? From file input the class. Now I going to use my child class. See, if you are using a result of student, what I'm trying to say is you are trying to innate the properties from your parent. Whatever the method you have, right? You can able to reuse in the child class. I give a proper example for you. Like what are the mom is having land as well as sovereign of gold. You can take that property right after some period you will take that land as well as properties as well as the jewels you can take, right? Same thing, you are trying to innate the properties. 1 minute.
This conference will now be recorded.
Now I'm trying to innate the properties from my class. That is nothing but the inheritance concept, which actually comes under the OOPS, object oriented programming language. Okay, we're going to discuss it later. Now what I'm going to do, I'm going to have one function. Okay, this is my existing object. Okay, you should not touch this object because the lead said to you it's already existing object. It's object based function. Okay, now I'm going to have one method called result or calculate result. We can keep calculate result, and then you have to pass the first parameter as class instance. Okay, instance you have to pass and then comma marks. Then I'm going to use a print statement. I'm going to have uh, your current score. Current score is comma marks. Now you're going to say, I want to pass this function as a parameter to the decor function. What will do? You have two ways actually. You can use py syntax. You can use otherwise you can call decor of. You can pass the call of result. You can pass. Okay. Now I'm going to call the py syntax. Make it mute. You can call the py syntax, but if you want to call this decor, directly you can't call decor. You can see that's the beauty here. What you have to do, you have to refer the class name with method name. Okay. Now I'm going to use a class name. The class name for the parent the class actually student dot decor. Student dot decor. Because previously it is the same class actually, right? Previously it is the same class. That's why using at decor. But this decor is in parent class. Then you have to refer the class name dot method name. If you're not able to understand, I'm writing syntax for you. Class name dot method name you have to call. That's it. Now, what you can do? Now, I want to call this method. How to call this method? I want to call this calculate result because I want to pass some marks, right? If you pass some marks, then only this calculate result will be passed as an argument to this function. Now you need to say how to call this calculate result method. I want how to call, how to call. Yeah, a few minutes back you said to me, right? Same thing you have to apply. First you want to create an object for the which class? Your child class. Keep some class instance or an instance equal to for a student class you want to create a object result of. Okay, now what will happen? You are creating an object for the result class. Though you are trying to inherit all the properties from a parent class, and then you're going to reuse in the child class, right? Now what will happen? It is going to create a single object. In single object, you can able to access your current method as well as your parent class method, because you are creating a single object for both for parent as well as child. If you're creating like this, what will happen? The result is going to call your, you're going to create object for this class. The result class is going to inherit the properties from the parent class. Now it's creating a single object. Now you can able to access this method, or this method also you can access. But as of now, I want to call this method. So I'm using object one dot calculate result. In calculate result, I want to pass some marks. If I now what will be the result? Now what is the result actually?
D.
Don't say like that. First, what you have to do? You're going to calculate as 55. Okay, calculate as 55, and then you're going to pass this function as a student decor, and then this function is passing argument to this method, and then what will happen? It's this decor function is going to return the grade, and then it's going to call the grade function. In the grade function, you're going to call the func. Func means nothing but instead of func, you substitute calculate result. It's going to call this method. Your current score is 55. After printing this your score, current score is 55, then it's going to compute. If marks less than 35 means it's going to print grade F, but I get marks 55. Okay, now it's going to print like grade D. Okay, I'll get the two results. One is your current score is 55, and then its grade is E. You can see the results. I think it's minimized. Yeah, you can see your grade is 55 and the grade is D. This is how you have to call the method. If you have a class, you have to create object for the class. Okay, no need to worry about student. Okay, because we are trying to inherit the properties from parent to child. So you can create object for child class. So you can able to access this parent class. Now we're going to show how to access parent. Let's see. From a child class object, I can able to access my decor function. You can able to see, right? From a child class object, from the class instance, I can able to call my parent class object function. I'm saying parent class function, because we are trying to inherit the properties parent class to the child class. So it's going to create even single object. From single object, you can able to access this method as well as this method you can access. If you are not using inheritance, you can't able to see here. If you are not, see, when you run this things, you will get some error. Okay, that's why you have to inherit the properties of a parent class to the child class. Now I'm going to have one more example. Calculate result. Then I'm going to have like 100. Now what's the result? What will be the result actually? If I call this method, what will be the result actually?
Your current score is 100.
Mm.
Grade A plus.
Grade A plus. That's the result actually. This is how you can use a decorator. See, without touching my old function, I can be able to achieve my new functionality. These are my new functionalities. As per client requirements, saying to give the new requirements. Okay, and then if you have multiple requirements, if you have multiple requirements, okay, you have some multiple requirements, then you can go for chain decorators. Okay, you can use one more decorator, and then whatever results you're getting, right, that result will pass to the another function, and then you can do the changes. Okay, you can use the chain decorators, chaining decorators. This is a use of you can use decorators in the class as well. Using class, you can use the decorators. Okay, as well as you can have multiple classes, and then you can use the decorators. Now the next topic you're going to see the memoization. It comes under decorators. It's a very hot topic actually, memoization. Those who are working in the performance development area, for example, if your program wants to run very faster, then they'll go for the memoization. Memoization means, simple term is saying memorandum. You have to remember your past. Remember your past. I'm going to give one example for you. Example. I'm going to calculate 5 factorial of 5. What's the value? It's 120. Calling this method, it's going to give 120 result. 120 as a result. Again, I'm going to call factorial of 5. Again, we'll try to compute results. If you are calling the same function again, what will happen? It's going to perform same calculation. It's going to perform the same calculation. If memorandum, sorry, if memory memorization is not there, what will happen? It will do the same calculation again. It leads to a performance issue. If I save the results in memory, what I can do? I don't need to perform same calculation again. Directly I can go to the memory. For factorial 5 I can get 120. It will reduce your computing effort. Okay, memoization can be achieved through only decorators. In simple terms, I'm going to say memoization is memorandum. You want to remember your past values. San, from childhood, you remembering all your past, right? What happened in the 8 years old, 10 years old, you're remembering all the past things. If someone asking your past, from the memory, you are taking that incident and then showcasing to them. You are saying to them, what this is what happened the 8 years back, this is what happened 10 years back. You are saying all these things to them, right? From memory you are taking. You won't go on 8 years back and then you won't compute all the results. That is the use of memoization. Okay, results of method calls based on the method inputs and the returning the remembered results rather than computed results again. What they're trying to say is, whenever using same method again, no need to recompute the same calculation again. Instead of calculating the same results, why you can't store them in memory? If you store results in memory, you can take the results from memory instead of unwanted computations. This is one of the good feature in Python. And then when you will go for repeat calculations, already in C languages you heard about recursion. I heard about recursion. Recursion nothing but until some specific thing is satisfied, it will keep on calling the function again and again. Recursion nothing but it will keep the calling the function again and again. That is nothing but recursion. It will be keep on calling the function again and again. That is nothing but recursion. In this, if you are using recursion in your program, then you can go for the memoization. You can keep all the values in memory, and then if you're computing the same factorial of 5 again, you can take the previous results on memory instead of computing the same thing again. Okay, now I'll talk about recursion. Recursion nothing but until some it will keep on calling the method again until some specific condition is satisfied. Until some specific condition is satisfied, keep on calling the function again. I've already heard in the terms in C and C++. Keep on calling the function. Keep on calling the function again and again. Now I'm going to implement the recursion approach for a factorial number and as well as Fibonacci series. Okay. Now I'm going to have a recursion program, and then after doing the recursion program, I'm going to show how to implement the memoization using decorators. Okay, now I'm going to have one py file. I will do one thing. I have some entry programs, right? I have entry programs. Where is my entry programs actually? Where is my entry programs folder? Interview programs. Okay, I'll keep this program in the oops concept. Okay, I'll keep in the program in the looping concept itself. The program name is factorial using recursion. Factorial using recursion. Now, I'm going to have a factorial number using recursion. How will you perform the factorial number? You know, like fact into fact star I, right? You know already fact into fact star I. Now, I'm going to implement the factorial number using recursion. I'm going to have one function factorial number, and then I want to pass one argument that's called number, and then I'm going to have one condition. If number equal to 1, sorry, equal to 1, then I'm going to return the value as 1. I'm going to return the value as 1. Hold a minute, I'm getting some. Okay, I have missed the colon. Number equal to 1, return 1, and then else block. I'm going to mention return number. What are the argument they pass, right? Number into what's the method name? Fact into num minus 1. Fact into num minus 1. Now what will happen? I'm going to pass the number as 5. Keep in mind, I'm going to pass the number as 5. Number values 5 are going to pass. You check for a condition. If 5 equal to 1 or not. No. The boolean value is going to be false. Then you come to the else condition and then substitute num equal to 5. 5 into factorial of 5 minus 1 will be 4. Again, this method will be called again. And then now the number value is 4. 4 equal to 1. The condition satisfied. And then come to the else block. And then the previous value was 5, right? 5 into 4 will be 20. 20 into fact of 4 minus 1, 3. Now again call the again for same function factorial of 3 and check for if condition and we'll come to 20 into 3 60 will come, right? 60 into factorial of 3 minus 1 factorial of 2. Again this function will call. This is nothing but recursion. The recursion will be calling the function again and again until some specific condition is satisfied. Until you're getting 1, it's keep on going to the else block and then it's going to call the function fact function say repeatedly. That is nothing but a recursion. Now if you want to call this method, what you can do, there you can have a fact of 5 and then use some print statement. Now you're going to answer for my question. Result is 120. If I call this method again, what will happen? Again, it's going to give 120. Again, it's going to call 120. If you call third time, the 3 times you're going to perform the computation, right? 3 times you're going to do the computation. 3 times it's going to do the computation. In order to avoid this, what we're going to do, we're going to implement the memoization using decorators.
This conference will now be recorded.
Now I have used print statement over here. In the print statement you can see it's called around 15 times. You can see 4, 4, and then 12, and then results of computing is 20, right? Totally 15 times the computation has been performed. In order to avoid this thing, what will happen? Only one time in the sense only like in 5 iterations, I can say 5 iterations it has to compute the result. After that, it has to store the results in memory. If you call the same method again, it has to take the results from the memory in order to avoid the computation again. Okay, memoization is nothing but a memorandum. It will store the previous results in the memory. Store the previous results in the memory. It's one of the powerful tool actually in order to improve your performance. Now I'm going to have one example for memoization using decorators. This is going to the last program actually today. Open the decorator folder. Keep some program name as decorator underscore 10. Decorator underscore 10. Just maximize the screen and then give the close of the top tabs. Okay. Now I'm going to use the memorization concept. I'm going to store all the previous results in memory, and then whenever computing the same function again, I'm going to take the results from the memory itself. Okay, I'm going to have the same factorial program, basic program, factorial program with memoization. Memoization means you're going to keep in the memory. That's it. Memoization, what spelling? Okay, memoization using decorators. Using decorators. Now I'm going to have one variable called memory. See, you can give any variable name. Okay, I'm going to have one dictionary. It's an empty dictionary actually. It's a empty dictionary. Empty dictionary. And then I want to implement the decorator function. You should have one enclosing function, and then you should have one more wrapper function. Def of what I can do. I can give like a name as memoiz. Memoiz means memoization. Memoiz of factor. You can give any name. You can give your name as well. Memoization of factorial. You have to pass the function as an parameter. Okay, and then inside the decorator function, you should have here one wrapper function. Wrapper function, or you can say nested function. I'm going to have wrapper function. In the wrapper function, I'm going to have one argument called number, because factorial you have to pass some number, right? Number. And then I'm going to have one condition. If I'm going to some membership operator, if number not in memory, number not memory, whatever value you're giving, right? 5 I'm going to pass a factorial number. If 5 is not present in memory, now it's not going to present because it's an empty dictionary, right? Dictionary means key and value pairs. Okay, I don't have key as of now. I only created only empty dictionary. If number not in memory, now what I going to do? Though you know dictionary is key and value pair. Memory of num, if I pass 5, it's going to take the key value as 5 equal to, and I'm going to assign some value. What value going to assign in the sense? Function of num. Function of num means my old object I'm going to pass here to my decorator function. It will compute the results, and then it is going to store the results, okay, in the my memory. Memory is nothing but as of now, for my understanding, I kept it dictionary now. It's every dictionary. If I pass 5, memory of 5 value will be computed. What's the 5 value? If it's factorial number, 5 is 120. 5 it will store like this. It will store like this. 5 is a key, value will be 120. Like this, it's going to store. This and then I'm going to have one else statement. I don't have multiple conditions. I'm going to have one default condition. That's why using else block. If I have multiple conditions, I have to use elif. And then I'm going to print something like what I'm going to do. Print something like returning results of shared memory. Returning results from the saved memory, and then I'm going to have one more print statement over here. Print results result saved in memory. And then what I'm going to do, I'm going to have one return statement, and then I'm going to have from this memory I want to take the value, right? Memory of what value you are passing. I'm going to pass some key value, right? To pass key value of 5, it's going to key value, for example, you keep like this. 5 is 120. What's the 4 factorial number? What's the 4 factorial? 4 into 3 into 2 into 1. 24, right? 24. What 3 factorial number? 3 is 6.
6.
2 factorial number is 2. 1 factorial number is
1.
like this. It's going to store results in memory. If someone passing old object, if someone passes the old function to my decorator function, if they pass the number value is 5, it will going to check the results. For example, passing 5, it's going to check whether it's present memory or not. If it's not present memory, it's going to the else block, and then it's finally going to return statement. The memory of 5 will be, it's going to give 120. It's going to give 120. First we'll check the condition. If the num value, what are passing the value is not present memory, it's not present memory, it's going to compute. If it is in the memory, it's going to the else block, and then it's going to give the value present in the dictionary. Keep in mind, it's going to print the value in the value from, it's going to take the value from the dictionary. If it is not present in dictionary, it's going to compute that factorial number and going to store the results in the memory of num. Okay. Now, okay, leave as it is. I will, for understanding, I kept all these things. I'm going to make this dictionary as empty dictionary. Now, I have written here what function I written. Decorator function I used, and then if someone calling this wrapper function, it's going to give memory of num value. Memory num means it's a dictionary actually, right? I want to pass a key value to result, and then come out of these things, and then have one more return keyword, and then use wrapper function. Wrapper function. Okay, that's it. Okay. Now I'm going to write one program for factorial number that is going to my old object. Okay. Now def factorial of num condition. If num equal to 1, return 1. Else return what I written, num into, same like factor into factor, right? Same thing, like, okay, num into so it's recursion, right? So it's recursion. Fact of num minus 1. Fact of num minus 1. Now you have to say how to call the old object as a parameter to the current object. You want to pass a function as a parameter to the another function. How to pass? There are two ways. There are two ways. What is the first way?
Use pi.
Use pi syntax at the rate of Memoize factorial. Memoize factorial. Okay, that's it. Now you're going to say how to call this function. I want to call the function a fact function.
Instance. Give an instance.
Why you need a for instance? Though there's no class actually. Here we don't have any class. Do you have any class? Then what's the need of creating object? Okay. You can use a print statement. Directly you can call fact of 5 can pass. If you pass fact of 5, what will happen? It going to pass this function as a parameter to this memorize factorial, and then it's going to call this wrapper function. This method is going to return the wrapper function. It's going to return the wrapper function. It's going to call this wrapper function, and then in the wrapper function, what are the value of past 5, right? The 5 value will substitute over here, and then if condition going to check if 5 not in memory. It's not present, right? It's not present. If 5 not in memory, then what it's going to do, right? Instead of function, you want substitute factorial of number. Okay, it's going to pass the value of 5, and then it's going to compute all the results, and then it's going to give 120. The number value is 5. Memory of 5 value is 120. In the dictionary, it will be storing like this. 5 value will be 120. And then though it's a recursive thing, right? Though it's a recursive one, and then now automatically it's going to call the function again. Now 5 minus 1 will be 4. 4 factorial is going to 24. 4 factorial is going to be 24, and then 3 factorial is going to be 6. 2 factorial is going to be 2, and 1 factorial is going to be 1. It's going to store all the results in the memory. Now we're going to show the difference. We're going to see now. I'm going to run the script now. Okay. What will happen? It's going to call this function for around 5 times, and then every time you can see the result saved in memory. It's going to show the result as result saved in memory 5 times. How many times it printed? 1, 2, 3, 4, 5. Because 5 factorial, 4 factorial, 3 factorial, 2 factorial, and then 1 factorial. If you multiply all these things, what do you get? Finally, 120. Now I'm going to show what's the use of memoization now. I'm going to have one more print statement. For understanding, I'm going to give some asterisks. I'm going to call the same function, same argument. See, now we're going to show the difference. First, we'll compute all the results because 5 times the recursion happened, right? 5 factorial, 4 factorial, 3 factorial will happen, and then it's going to store every results in the memory. In dictionary, we have 5 factorial 120, 4 factorial is like 24, 3 factorial nothing but 6, 2 factorial nothing but 2, 1 factorial nothing but 1. We're going to store all the results in dictionary. We're going to save the results entered in memory actually. Now, if I use the same function again, whether you will get all these things? That's my question. Again, it's going to perform same iteration? No, it's not going to perform same iteration again. It's going to take from the memory and going to give the result as only 120. You can see the difference. See the first computation for understanding it kept like this: 5 factorial, 4 factorial, 3 factorial, 1 factorial. Finally, the result 120. I'm calling the same factorial of 5 again here. What I'm getting here? Results returning results from the saved memory. What will happen? It first will go to the if condition again. You go to the if condition. Again, you're doing 5 not in memory. You're doing here 5 not in memory. 5 is already exist, right? Directly come to the else block, and then it's give the print statement, return results from the saved memory, and then from memory only take the value. This stuffs won't happen. these calculations won't happen. If I call third time, what will happen? Again, it's going to take from the memory only. Let's see what happened here. Why getting this much things? Okay. I did a blunder mistake over here. Fact of I given. I want to use print of fact. Print of fact of 5. Okay. The results. Where it's getting the value? Getting from the memory itself. It's not doing all this calculation. First time only do all the calculations, just keep our memory. After that, from the memory, it's getting the results. 120. Okay, I'm going to sign off the session right now.